We are going to continue our topic about factoring polynomials, especially quadratics. Today's lesson we are going to talk about two special type of trinomials. One is the perfect square and the other one is the difference of squares. If you recall from previous lessons, we said that if we expand the binomial a plus b or a minus b squared, we are going to get a squared plus or minus 2ab plus b squared. Depending on the sign between a and b, we get either plus 2ab or negative 2ab. And also, we said that if you find the product of a plus b and a minus b, you get a squared minus b squared. We can use this fact to factor out the difference of squares or trinomial of perfect squares. So the process is very simple. Again, the first thing you always do for factoring is try to see if there is any common factor. If there is, you take the common factor out, then you are going to be left with another polynomial. Now, if the polynomial is a trinomial of this form, a squared plus or minus 2ab plus b squared, then the factor is a plus b or a minus b squared. Or if you get a trinomial of this form, a squared minus b squared, a binomial, a squared minus b squared, then the factor is a plus b times a minus b. Now, the good news is that you don't really need to memorize these formulas. What you have learned so far, you can use it to factor a binomial if it's a perfect square, or if it's the difference of the squares. For the first example, let's say we have x squared minus 100, and we're supposed to factor this one out. I can write this one as x squared plus 0x minus 100. 0x is just 0, so I can add or subtract 0 from anything. Now, if you look at this one, first of all, there is no common factor. Second of all, the leading coefficient a here is 1, so I can use the sum and product method. I have to find two numbers that they multiply to negative 100 and add up to 0. The only two numbers that I can find is 10 and negative 10. If you multiply 10 by negative 10, you get negative 100. If you add them up, you get 0. So you see that the factors are x plus 10 times x minus 10, which is exactly what we said before. A squared minus b squared is a minus b times a plus b. Now, a is x, b is the square root of 100, which is 10, so it's x plus 10 times x minus 10. Now, the next example, we are going to factor out the binomial 98a squared minus 450b squared. First of all, we have to do the common factor. The common factor here is 2. So, if I take 2 out, I get 49a squared minus 225b squared. Now, 49a squared can be written as 7a the whole thing squared minus 15b the whole thing squared. Now I have again square and squared and the difference between them, so I can write this one as 7a plus 15b times 7a minus 15b. And this is my factor. Now we can do another example. Let's say this time we have x squared plus 6x plus 9. The square root of 9 is 3, so I can write this guy as 3 squared. The square root of x squared is, I can write as 1x squared. Now, if I multiply 2 by 3 by 1, I get 6, which is 6x. So this is a perfect square. So I can write this guy as x plus 3 squared. Again, that's one way if you memorize that formula that we presented before. Another way of doing it is very simple, is that since the leading coefficient is 1, I can use the sum product, and I'm going to find two numbers that they add up to 6 and product is 9. So those two numbers are 3 and 3. So I can say x plus 3 times x plus 3, which is the same as x plus 3 squared. So either technique is correct. Now we are going to do the next example. The next example is factor x squared minus 12x plus 36. Now to do this one, again, x squared can be written as 1x squared. 36 is 6 squared. Now if we multiply 1 by 6, which is 6 times 2 is 12, you get negative 12. So this is a minus b squared. So I can write this one as x minus 6 squared. That's one way. Again, another way of doing it, the leading coefficient is 1. So let's try to find two numbers that the product is 36, but the sum is negative 12. So those two numbers is negative 6, negative 6. So the answer is x minus 6 times x minus 6, x minus 6 squared. So either way is correct. Which method to use, it's up to you, which one you feel comfortable. Now the next example is first asking us to show that this trinomial is a perfect square and then factor it. I can write this trinomial as 2x squared, 49 as 7, and 28 as 2 times 2x times 7. And again, remember, a squared plus 2ab plus b squared is a plus b squared. So I can write this guy as 2x plus 7 squared. Another way of doing it is to use the technique that we had before. Since the leading coefficient is 4 and it's not 1, I am going to multiply 4 by 49. So I'm going to say 4 times 49, which is going to give me 196, and b is equal to 28. Now I have to find two numbers that the product is 196 and their sum is 28. Those two numbers that give us the product 196 and the sum 28 are 14 and 14. So I can write the middle term 28x as 14x plus 14x, which is 28x plus 49. Now I take these two terms and then these two terms and factor the common one. So from the first one I can take 2x out, so I get 7x plus 7. And from the second one I can take 7 out, so I get 2x plus 7. Now both of them have 2x plus 7, so I take 2x plus 7 out. So I get 2x from the first one plus 7 from the second one. Both of them are the same, so I get 2x plus 7 squared. Exactly like what we got before. So as you can see, you can either use the new technique, which is the perfect square, or we can use whatever we had before. Again, which one you prefer to use is the one which is the right way of doing it. Now let's do the next example. The next example is almost the same as the previous one, but now you have two variables, k and m. First, we have to show that this is a perfect square and then try to factor it. Now, to show that this is a perfect square, I'm going to write the first term as 5k squared, the last term as 6m squared. Then I can write the middle term as minus 2 times 5k times 6m. Now 2 times 5 is 10 times 6 is 60, so you get minus 60km, which is exactly the same thing we have here. So I can write this guy as 5k minus 6m squared. That's again one way. Another way, if we use what we had before, since the leading coefficient is not 1 and there is no common factor, I'm going to find the product of AC, which is 25 times 36 m squared, which is going to give me 900 m squared, and B is negative 60 m. Again, find two numbers that they add up to negative 60 m, and the product is 900 m squared. Those two numbers is negative 30m and negative 30m. So this means I can break the middle term into two terms. So I write 25k squared minus 30km minus 30km plus 36m squared. Now I take the first two terms and the last two terms, and I take the common factor. The first one, the common factor is 5k, so I'm going to get 5k minus 6m. And the second term, I'm going to get negative 6m out. So negative 30km divided by negative 6m is going to give me 5k minus 6m. Now 5k minus 6m is common, so I take 5k minus 6m out. So I get 5k from the first one here, and then negative 6m the second one. Now these two terms are the same, so I get 5k minus 6m squared, which is exactly what we got before. Our last example is the following. First, part A, we have to find an expression which represents this shaded blue color region here. And it's obvious the area of this region is the area of the bigger rectangle, subtract the area of the smaller one. So I can write A is 3x plus 8 squared, because area of a square is one side squared, minus the area of the middle one, which is x minus 2 squared. So that's part A. Part B asks what is the factored form of this area. So the area is given this way. Now if you see, this one is really a squared minus b squared, so I can write this one as a, which is 3x plus 8 plus x minus 2 a minus b. So 3x plus 8 minus b. So minus is going to be multiplied by every term inside the bracket. So negative x plus 2. Now if I simplify it, 3x plus x gives me 4x. 8 minus 2 gives me 6. And 3x minus x gives me 2x. And 8 plus 2 gives me 10. So this is the area in factored form.